So we've been talking about the atom and how to draw the atom. Today we're going to add three new important concepts that have to do with atoms. The first of those is called the octet rule. Again, things that are underlined are things that you should write down. The octet rule states that atoms prefer to have a full outer shell of electrons. Now, that number changes based on which shell we're looking at. So which shell is the outer shell of the electron? Just as a reminder, the first shell can hold 2 electrons, the second shell can hold 8, and the third can hold 18. And again, there are further shells after that, but we're not going to go past 3. This is called the octet rule mainly because we're looking at this second shell. And the second shell likes to have 8 electrons. So think like octopus, 8 arms, 8 electrons, octet rule. So atoms prefer to have a full outer shell, and most of the time that'll be 8 electrons. The next important concept is called valence electrons. So valence electrons are all electrons in an atom's outer shell. So going back, the outer shell could either be the first, second, third, and so on. The valence electrons are simply the electrons that live within the outermost shell. Okay? And the reason they're important is because they participate in what are called chemical bonds. We'll learn about those later. Just know right now that valence electrons are all electrons in an atom's outer shell. So let's do a little example. Try to count how many valence electrons there are. In this first picture on the left, we see Li, which stands for lithium. Okay, and in this Bohr model, there are 2 shells. The outer shell is the second shell, and it has 1 electron in it. So to answer this question, how many valence electrons, I say lithium has 1 valence electron. In the second picture here, we have silicon. Now silicon has 3 shells, and if I'm interested in the valence electrons, I'm only going to look at the outer shell. And in the outer shell, I can count 1, 2, 3, and 4. So silicon has 4 valence electrons. The last concept that we'll talk about today is called electronegativity. And you'll notice that the octet rule, valence electrons, and electronegativity all go hand in hand. The definition of electronegativity, which is underlined, you should write it down, is how much an atom wants to gain an electron. Another way of saying that is how badly does this atom want to take in more electrons? Okay? In order to understand this, we can answer this question. Why would an atom want to gain electrons? Well, we can go back to what we talked about earlier, which is the octet rule. Atoms want to fill their outer shell. So it makes sense that an atom would want to gain more electrons in order to get closer to filling their outer shell. Electronegativity can also be understood as the closer an atom is to having 8 valence electrons, or that full outer shell, the more it wants another. So let's go back to these 2 pictures right here. Again, lithium has 1 valence electron, silicon has 2. Because silicon has more valence electrons than lithium, it is closer to having that full outer shell. So silicon has a higher electronegativity. Let's take a look at another example here. Here I've got oxygen and I've got fluorine. Take a second on your own right now and count the number of valence electrons that oxygen and fluorine have. And remember, valence electrons are simply the electrons that are in the outer shell. Oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer shell. Fluorine has 1, 2, 3, 4, 5, 6, 7. All right, now let's think about this. The closer an atom is to having 8 valence electrons, the more it wants another. So we can say that fluorine is more electronegative than oxygen because it's closer to having 8, that full outer shell. It really, really wants to get that other one. So it's more electronegative than oxygen. So here's some practice for you. Draw Bohr models for the following atoms. Count the number of valence electrons, then determine which has the higher electronegativity. Here's a hint. Silicon with an atomic number of 14 is going to have 14 electrons. Phosphorus, an atomic number of 15, is going to have 15 electrons. And they're both going to have 3 electron shells. So take a minute on your own. Try to figure these out.